Friday, we had a work day, and I checked B13, which was the the test review. So after the notes, I'll come see you, those of you that weren't here, to see if you have it, okay? And then just some reminders, the quiz is due tomorrow. The quiz is due tomorrow at 11:45, don't forget. Our next and final homework check will be this coming up Friday. And today we're doing section 2.11. It's just a one-day section. And then we have 2 days of 2.12. So we only have 3 new lessons left for this semester, okay? Today, tomorrow, Wednesday. Then we'll do our test review. I'm actually going to give you guys 3 days to work on the test review instead of 2, just because we have the time. And I just want you guys to be really prepared. That'll also make sure that our test isn't on a Monday. So when I can prevent a test being on a Monday, I do try to prevent it. So test review will be Thursday, Friday, Monday, and then test Tuesday and Wednesday of next week. Okay? So 3 new lessons, that's all we have. Great. So we have, of course, notes and homework today. Just to give you a heads up, listen, first and second period, I think, finished the homework in class. And I'm telling you that because I don't want you to feel rushed. And especially, like, we have 3 examples to do today. The first 2 are real quick and pretty simple. The third one's really involved. It's got a lot of parts to it. So I don't want you to feel rushed. I want you to take good notes when we do it, because there's one just like it or very similar to it in the homework, okay? And it's also an FRQ on your next test. So I'll explain all that again when we get to that problem. But let's do like a quick review of what we've already learned. We're still working with log functions, and here is the parent function of a log. F of x equals log base b of x. And in the parent function, we have an x-intercept at 1, 0. Doesn't touch the y-axis in the parent function because the y-axis is your asymptote, okay? So if I sketch this, it would look like that. That's what basic log function looks like. If the b is greater than 1, it's increasing. So this is an example of b being greater than 1. If b is less than 1, but also greater than 0, which means like 1/2 or whatever, it would be more like, I have a hard time drawing it the other way, like this. It would be decreasing. So remember, the b, that little b, if it's greater than 1, we're increasing. If it's less than 1, the graph is decreasing, okay? So those are just some things to remind you of. And so here's the thing. We've been doing problems where you had to graph logs using your graphing calculator, right? You put it in there. And one really cool thing about graphing logs in the graphing calculator is you can use your table to find your asymptote, right? It's where the first error is. But that's not going to work 100% of the time, and I'll explain why in a second. And you might get this type of question without a calculator. So these would be questions that you would get on a non-calculator part. So we don't want to rely on our calculators for these. So what we're going to do is find the domain without the calculator, and we're going to state the vertical asymptote, okay? Really, really simple to do. What we learned last week is that this x value right here can never be 0. And it's also not going to be negative. It's never going to be 0, and it's not going to be negative. If there is a negative number in there, it's actually a flip over the axis. You'll see what I'm talking about here in a second. I'll show you exactly what I'm talking about. But what we can say that we know is that x plus 5 has to be greater than 0. X plus 5 is greater than 0. X plus 5 is greater than 0. And so if we solve this, what we find is that our domain is all the numbers, all the x values that are greater than -5. That also gives you your vertical asymptote at x equals -5. Let me show you what it looked like. So if I did put it in my calculator, I would be able to see right there in my table of values that there's an asymptote at -5, and all my points are going to be greater than that. So they're all going to be over here. It would look like this. Okay, now, not asked to graph those. I'm just making a point of that's what it would have looked like. And it's a really simple way to find your domain. So that's your domain. And find your VA. So that's written, you can write it like this too, -5 to infinity. Okay. So that's our domain. Let's look at another one. Set my 5 minus x greater than 0 and solve it. Subtract 5. That leaves me with negative x is greater than negative 5. Don't forget, that's a negative 1, right? Divide both sides by negative 1. And it's been a while since you had to remember this, but do you remember what happens when you multiply or divide by a negative number when you're solving an inequality? You flip, you have to flip your inequality symbol. Okay? I haven't had to do that in a while, right? So your domain would be all the numbers less than 5. So that's from negative infinity to 5. And 5 is your vertical asymptote. X equals 5. This is a really simple way of doing it. A quick sketch of that graph just to make sure you guys understand. We would have a vertical asymptote at 5, and all of our x values are this way. It would look like something like that, roughly. Okay. Now, why is this helpful? Well, for one, it's helpful because you're going to have questions like this without the calculator. But what if this was your, what if you had to do this one? And I put it in my calculator. So I put it in here and I go to my table, and if I use my table, what would we think our asymptote is by looking at our table? 0, right? That's our first error. So if we use that way of doing it, we would say, oh, vertical asymptote is our first 0. But if we do it by hand, it's not. What is it? It's 1/2. Why doesn't our calculator tell us that? It's counting by ones, Haley, exactly right. Remember, our calculator defaults to count by 1. If I changed it to change to 0.5, then look at your table. 0.5 is actually the first error that you get to, okay? So you have to be careful with the calculator part. You can take a quick glance at your whatever's in parentheses and say, oh, that's going to be a whole number, right? If there's nothing you're going to divide by, if it's just x plus or minus something, you know it's just going to be, you can see it in the chart. But you have a backup plan if need be, okay? So you have a couple problems like that. Let's look at example 2. We have 4 logs graphed and 4 logs in equation form, and we're going to match them up. So 3 of them have a log base 2, one has a log base 1/2, and then the only other difference between them is where the negatives are. Remember, when the negative is inside the parentheses, that's a flip over the y-axis. When it's on the outside, it's a flip over the x-axis. And you can have both. You can flip over both axes. You don't have them here, but you could have double negatives. All right, so let's look at f of x. This looks like a pretty basic parent function, log base 2 of x. All right, that means x equals 0. Well, remember what we just learned. If I set what's in parentheses greater than 0, I can see my asymptote's at 0, and all my points are going to be to the right. Okay, so if I look at my choices, I either have B or C. One of these is going to be f of x. B is 2. B is greater than 1, right? So whenever B is greater than, yes. Is that what I meant to say? Yeah, sorry, I lost myself for a second. That shows growth. It's increasing. And we just talked about that. When B is greater than 1, our graph is increasing. So between these two, this is the one that's increasing, right? This is f of x. It's like the parent function, okay? Let's look at the next one. That is a flip over the y-axis. That flips over the y-axis. That means all of our points are going to be to the left of our asymptote. Okay? All my points are going to be to the left of my asymptote. That gives me either this one or this one. But think about it. At its most basic, it's just a flip. If I took f of x, this graph C, and flipped it, which graph would I get? A. Yep. This is our g of x, which is, that just flipped it right over the x-axis. So moral of the story is, when x is positive, all your points will be to the right of your asymptote. If x is negative, it's not truly negative, it's like a -1 in front of the x, it flips it over the y-axis, and all of your points will be to the left of your asymptote. In h of x, it's the same as this graph, but flipped over the x-axis. X is positive, all of our points should be to the right of the asymptote, so we're only down to these two, so it's got to be this one, right? This one is h of x. Which leaves this guy to the left of our asymptote because it's negative, okay? But I want to point something out to you here. When we flip over if we have any flips in our function, that b value no longer means stretch or shrink as it looks. Like, look at base 2 here, this graph. That's actually a decreasing graph. That's decreasing. Even though we said when b is greater than 2, it's increasing, that's only when this is positive. So just be aware of that. It worked for this one because it was the only one that didn't have a negative in it. B is greater than 1, so it's showing growth or increasing. So yeah, sometimes I have to use other parts of the function to kind of match it up. And that right or left of the asymptote is a really good way of doing it. Okay. So those can be confusing. Okay. The last example, this is the one that's involved, it's got a lot going on, is actually in the last lesson. It's on page 120. This is going to be a great review of so many things we've learned. It's really putting a ton of things together. You're going to have a homework problem similar to this one, and the FRQ on your test is very similar to this, okay? So it's a very valuable question, plus it just covers so many different things that we've already learned. It puts it all together. It's a fabulous question. And there's one new thing in it. So let's start by saying, okay, what we have. We have a table of values, and it's telling us what it is. It's an exponential function in that form. It's telling us that, okay? So we're going to use that table to answer all these questions, all right? So first thing it asks for is the end behavior of this function, okay? So it wants our limit statements, all right? So let's look at the table of values. Now, this is a no calculator, just so you know. You would not have a calculator on this. So we have to do everything from this table of values, which is not hard, okay? Let's take a look at our table of values. Let's look at our right behavior first. As I look at my x values, so my x values are just getting bigger. There's nothing stopping them. It's just steadily growing. So my x values are increasing without bound, is a way of saying it. Well, so are our y values. Look, they're just getting bigger. X's are getting bigger, y's are getting bigger as we go to the right, okay? So remember, I'm going to be very nitpicky about your limit statements. This is the limit of find the name as x, and it doesn't matter if you do left or right first. That doesn't matter. In this case, we decided to do the right. So as x increases, so does y. So there's my right end behavior, okay? Let's look at what's happening to the left, okay? So look at the x values. The x values seem to just be getting smaller, okay? But our y values, they're freely going down, right? Just happily moving along, going lower and lower. And then something changes. It's almost like the brakes got put on. Like, whoa, we're approaching something. We got to slow down. What are we approaching? What are we? 1. We're approaching 1, right? So the limit of g of x as the x's get smaller, right? As our x's just continue to get smaller, our y values are approaching 1. That's the sign of it. You can see it. It should be very obvious in the table of values, okay? In a log function, it would have been flipped. We would have had the 1 here. Remember, it would be like in the x values, we'd be approaching 1, and the y values would be going to infinity. But don't memorize. Look at the table. You can see it very clearly once I've explained it to you, I think. Now that I know that, now this isn't required, but it is helpful. Now that I know what this is, and I know that my y values are approaching 1 as I go to the left, I could do a quick sketch of this graph. So I just want to show you. That would put so let me back up. I should have said this. Whenever you have an exponential function, it makes a j. It's like the j graphs, okay, and logs are the other ones that we just saw on the other page a second ago. So now I know my x's are increasing and decreasing without bound. As I go to the right, they're increasing forever, but going to the left, they're approaching 1, okay? That means 1 is an asymptote, right? We can't go past it. It's stopping us from going down forever. We can only go down as far as 1, all right? That is your k value. K is your up or down. And in this case, k would be 1. It's stopping the graph. That's how far up we go, and then all the other points are above it, okay? Why is it? Because, what do I want to write there? Because k is the HA, or you could say or because of the left limit statement. Okay, and I think I rewrote the left-sided limit statement in the key to the homework. It's probably a better way of writing it. Because of this, that's how we know what k is, because of what we just said. Okay? Part C is asking for what is our b value. What's the base? What is the base? And we've talked about this many times. In fact, I think section 2.2 is all about how do you find that number. It's what you're multiplying by, right? So this is the part that's different. So listen. So we learned that in an exponential function, the y value should be multiplied by a constant number. Times 5, times 5, times 5, times 2, times 2. That's not happening here. So I need to analyze this table of values because there's no question that it is an exponential function. It told us that, okay? So we're not trying to decide if it is or it isn't. It is. Where is our b? Why isn't it showing up the same way? Well, it's there. It's just hiding. We have to do an extra step. Easy step, but we have an extra step to do. And so when I go to analyze this table of values, guys, I'm going to ignore these guys down here because I have plenty of points over here that are much easier to work with. So I'm going to ignore those, all right? So my x values are increasing by 1, fine. Now what's happening with my y values? Well, what you're going to notice is that we're adding 1 here. We're adding 2. We're adding 4. We're adding 8. We're adding 16. That's not multiplying, but what this is we're adding by 1, by 2, by 4, by 8, by 16. These are all base 2 numbers. These are all 2 to the power of any number. 2 to the 0 is 1. 2 to the first is 2. 2 to the first is 2. 2 to the second is 4, and so on. 2 to the third, 2 to the fourth. So it's hiding. Our b value is 2. It's hiding in there. The reason it's hiding is because of the h and k. Because it's like a layer that's hiding it whenever there's an h and a k, and you will see this again. And I feel like it's always these numbers. It could be +1, +3, +6, +9. I don't know. It could be like something else. This is pretty much what I almost want to say this is the one you'll see on your homework and on your test. We'll see. But we'll see it again. Very, very simple. But that b is 2. All right? Part D wants us to write this equation. Okay? Find all the points, the important stuff that we need from this equation using what information we have. So what I want you guys to understand is that this function right here, g of x, has 5 variables. 1, 2, 3, 4, 5, right? G of x is just y, right? 1, 2, 3, 4, 5. If I'm going to write this in g of x form, I want the b and I want the h and I want the k. Well, I have b and I have k. I don't have h. So what they're telling us to do is use a point in the table. They're telling us to use 4, 3, but truthfully, any point would be fine. Okay, so if it didn't tell you what point to pick, you can pick whichever one you want. So we're going to use x is 4 and y is 3, just so we're all using the same thing. We're going to use b is 2 and k is 1, and we're going to use that information to find h. And then we'll write our final answer. So this is just using our algebra skills, guys. Plug in all 4 that we know and solve for the 5th that we don't know. Okay? So start plugging into the function. Y equals my b value, x minus h plus k. This is an exponential function. We're going to solve an exponential function. We learned how to do this already. Before we can start, though, we want the base and its exponent by itself. So I have to move that 1 to the other side, which gives me 2 equals 2 to the 4 minus h. And whenever we solve exponential functions, what we are looking for is like bases on both sides, you remember. And we have that. 2 on this side, 2 on this side. Because if your bases equal each other, the exponents equal each other. And that's how we can solve for a power that's up in the sky like that. What is the exponent on this 2? 1, right? We don't write it. We know it's there, though. So if 2 equals 2, well, then 1 equals 4 minus h. And the bases are the same. The exponents are the same. So subtract 4 and divide by -1. You should get h is 3. Now we have all the information we need to write g of x. We're going to plug in b, k, and h. So g of x is base 2 to the x minus 3. That is the equation of that graph, that table of values. Okay? Domain and range. You can use your sketch of the graph, but remember, you didn't have to graph it yet. You could graph it and then go back, or, you figure out what you want to do. You could use the table of values, though. The domain is all real numbers, right? We already talked about that. The right and left. We can use any x value we want. The range would be, nope, 1. 1 to infinity, but not including the 1. Right? Okay. We are now in part F, which is find the inverse. Like, it doesn't say the word inverse. We know now that that symbol means inverse, or we should. So whenever we hear inverse, we say switch x and y, solve for y in this case. Okay? So I'm going to take this equation right here and switch the x and y. So g of x is y, right? So it's now going to be x. Guys, the inverse of an exponential is a log. We are going to be turning this into a log equation. Before we can do that, just like the first step in part D was to get the base by itself. We want 2 to the y minus 3 isolated on one side before we can write it as a log. So we're going to subtract 1 from both sides. Okay, so I have x minus 1 equals 2 to the y minus 3. Now we're going to write this as a log. To write something as a log, we start by writing the word log. Log. What's our base? 2, right? The base of your exponential is the base of your log. Remember how I taught this to you? Leave a space, if you want to. You can do it in any order you want. Put an equal sign. And the loner up in the sky, he's a loner. He likes to have his own side of the equation as well. He's always away. That leaves all of this. Guys, all of this means all of it. The x, the minus, and the 1. Which means it must go in parentheses. And remember, the goal is to get y by itself. Switch x and y, get y by itself. So just one more step, right? Add 3 to both sides. So the final answer would be use the right notation, log base 2. You have to have the x minus 1 in parentheses, plus 3. A way to help you remember that is in the exponential functions, there was an h and a k, right? So when we write it as a log, it should have an h and a k as well. Notice they're just flipped, h and k, because they're really just what x and y are doing. So that might help you. If you accidentally left the parentheses off, you would have added 3 to negative 1, and you would have lost one of your transformations. So hopefully that helps you. Almost there. Part G is to graph both of them on here. Let's make this really painless. We have some points, so let's graph those points, and then we will flip them to graph the inverse. So I'm just kind of killing two birds with one stone here. I'm giving you guys a sec to graph both of them. So I'm going to start off by graphing some of those points. That's g of x. I already flipped it. I'm going to graph some of those points. That's g of x, g inverse of x. Just remember your asymptote. If you have a vertical asymptote at x equals 1 for this guy, you're going to have one at positive 1 on the, vertically on that one. Just go ahead and be careful because these are counting by 2. That's good enough. Remember, having the asymptote on our graph prevents us from putting points where we shouldn't. So there's my g of x, the original guy. Get my asymptote on there and graph the flipped numbers. While you finish that up, remember I told you guys that whenever you graph a function and its inverse, it'll always be symmetrical across that identity function there. You can see it pretty clearly with this graph. If I could fold the graph at that diagonal line, the points would all meet up. Okay? Domain and range of the inverse. You have 5 million ways to figure it out. You could use the graph. You could just flip these, right? You can flip the domain range here. Whatever you want to do. So there's a lot going on in this problem, lots of good little reviews of so many things that we've done. When you get to the homework, you have one similar to this. But let me tell you the one difference, okay? Listen, the example in your homework looks just like this one. It's an exponential function, table values, answer some questions. The only difference is the b is not a b, it's an e. It's a base e. All that means is instead of using log in your problem, you'll use ln. ln is a base e. B can be any number, and then we attach a log to it. Log base 2, log base 1/2, whatever it may be. If that base is an e, that means it's natural log base e. So that's the only difference. Everything else is the same. Okay? So, homework is on page 133. It starts on page 133, and that's where you'll find the first part of the homework. The FRQ that you have to do is on page 127, which is actually on the other side of the first page of our notes today. So where we started in our notes, it's on the other side of that paper, page 127. Mm-hmm. So I'm going to put up through 19 up first, and then in a few minutes when you guys get 9, 11, and 12 done, I'll put the FRQ up. Okay, yeah, you weren't in here when I said it, but once I finish the homework notes, I was going to come around and see everybody was absent. And don't forget the quiz is due tomorrow, if you haven't done it. Tomorrow at 11:45. It's due. Is that what you asked me? What'd you say? Oh, 11:45 tomorrow night. PM. As close to midnight as I can get it. That's as close as I can get it, yeah. All right, let me see. Who was the absent? All right, I'm going to come see Haley, Fernando, Caitlin, Samuel, Zach for the homework check, which was the test review. I'm just putting this up here for 1 second for my video. So if you're watching the video and you want to pause it, please do this.